All right, so today we're going to do a little lab activity. And before we get into that, I want to play for you all a short video that is sort of the context. I will admit this is the first year that I'm doing this particular lab. It was something that I came across over the summer. There's a gentleman that I met while grading the AP exam who ran a website that used to be called StatsMedic. Now it's called MathMedic. And this was actually an activity that he recommended as an introductory activity for APSTAT. And I really liked it. And it also comes with a pretty cool punchline at the end that I'm going to wait and share. Okay? So I'm going to play a short video for you, and then I'll get into the activity. So the idea, just to quickly summarize it, was this woman noticed her husband's smell had changed. She didn't really know what it was. Later, he developed Parkinson's. And then they're attending meetings for people with Parkinson's. And she notices all of you have that same smell that I suddenly was noticing in my husband a couple years ago. And it dawned on her, I can smell Parkinson's. Now, obviously, this is kind of a claim that needs to be tested. You know, doctors and scientists were sort of skeptical of this. So they did a short little experiment with her where they had 6 people that they knew had Parkinson's wear a t-shirt. They had 6 other people that they knew did not have Parkinson's wear another t-shirt. And then they put all these 12 t-shirts in separate bags, and they essentially asked her to smell the t-shirts. Okay, now in a moment, we will run this lab ourselves. You'll do it in pairs. But the idea here is that when we run the lab, you will essentially have 12 t-shirts and you're just guessing, because I assume you all don't have the same power that she does. Okay, so you might say yes, no, no, yes, 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 no, no, yes. And, you know, 6 of them should be yeses, 6 of them should be no's. So at this point, I've already said yes 5 times. I can only say yes one more time. So I'll say yes, no, no. And hey, that's not bad. I got 8 of them right, apparently. Okay, so I was just guessing and got 8 of them right. And that's sort of the idea. Okay, so she got 11 of them right. And the question is that something that should arouse our curiosity in terms of, does she seem to have actual powers? Okay, so we're going to start with, I'm going to pass out a worksheet. I'm going to give you all time to discuss in your groups and complete the front page. You'll notice there's a stop sign in the bottom left corner. After we complete the front and kind of go through it, then we'll move to doing the actual lab. Front of the page. Normally what I might do is call on people at random and kind of get contributions, but I want to make sure that we have time for the lab. So I'm just going to kind of quickly go through the front. With the first question, why would it be important that somebody can smell Parkinson's? Totally a subjective question. So don't feel like your answer had to be the same as mine. I'm sure you all had other creative answers that I didn't think of. The one that occurred to me first is early detection. Okay, when it comes to a lot of diseases, the earlier you can detect it, the better off you are with treatment. So if we can detect a smell that is a precursor to developing Parkinson's, that's pretty awesome. I also figured, well, if a smell is connected to it, then maybe there's something chemically related that'll give us a hint as to what's actually causing Parkinson's. Okay, again, total speculation on my part, just an answer I came up with. All right. Moving on to number 2, it says, how many correct decisions would you expect? Now, this is less of a subjective question. I'm hoping we all kind of got on the same page with this one. Okay, anyone just shout out how many you'd expect her to get? 6. If she's randomly guessing, well then 6. She has a 50-50 chance of actually getting anything correct, so half of the 12. Now, just real quick, this is a color code that I'm going to use throughout the entire year. If you ever see something that's blue, it will always be bold, and I'm communicating to you that if I was completing a homework assignment or a quiz or a test, that is what I would write to try to get full credit, okay? If you see green, it will always be italicized. That is me saying this is extra information that would be good, like you should understand what it's saying, but there's no expectation that that would have actually been on your paper. Okay, this is actually a formula that we will use when we get into probability and we start calculating expected value. Okay, n would be considered sample size. That's the symbol we use for sample size. P is probability of success. So if you do n times p, you get the expected number of successes. Okay. Now, the next question, do we have some evidence? In a word, absolutely. But on the back, we're going to get into, but is it convincing evidence? It's easy to have some evidence of something, but is it convincing enough is really the distinction we're going to be interested in. Okay, so I said absolutely yes. In the end, we would have expected her to get 6, and she got 11 out of the 12 correct. So the fact that she beat the random guessing expected value, that serves as there's some evidence that maybe she's better than just randomly guessing. And maybe she does have the ability to detect something on some level. Now, the last one, we kind of get back to kind of a subjective question. How many guesses or how many matches would she have to get out of 12 to convince you? So I'm curious, again, just kind of popcorn answers, shout out numbers. What'd you say? 12? 11? Anybody say 10? 10? Anybody say 9? Nobody said 9? Okay. Very often I will get 9, 10, 11, 12. There are also some people that say, I don't even care if she gets 12 out of 12. I still don't believe it. Okay. I rarely get students that will say something as low as 8. And I certainly don't see 7. Okay. But I'm curious, can anyone just raise a hand, volunteer? Why is that the case? Why wouldn't somebody go with 7 or 8? Okay, so what she just said is 7 and 8 are too close to 6. You could probably get 7 or 8 just by guessing. So even if you wouldn't phrase it exactly the way she phrased it, I'm hoping you all can kind of agree your intuition would have led you down that same path. Okay, this is one of the things that I find beautiful about the world of mathematics. In my opinion, mathematics is nothing more than we're noticing patterns in the world around us. We're trying to put a structure to it. Okay. And this mentality of, well, 7 and 8 could just happen if you were guessing, that's a probability thought. That's you saying it could happen by chance. And the fact that it could happen by chance means it doesn't convince me of anything. Okay. And that's going to be a huge part of second semester when we get into hypothesis testing. The whole idea is that we go out into the world, we collect data, we ask ourselves, well, how weird is that? Could that have just happened by chance? And if the answer is no, like that's really weird, that shouldn't have happened, well, then it's probably an indication of something. Okay. So that's a big part of what we're going to get into in second semester. All right. Questions on any part of the front? All right, so now we're going to run a lab, just a quick simulation experiment together. You're going to be doing it in pairs. Now, I gave half of you a little plastic bag. On the inside, if you wouldn't mind, go ahead and take the slips of paper out and just verify you should have 6 t-shirts, quote unquote, that say yes Parkinson's, and you should have 6 t-shirts that say no Parkinson's. Okay, so just verify that that's true because I want to make sure none of the bags got messed up in between classes. Then you're going to mix them up. Okay, now our goal here is to investigate whether Joy's result could have happened purely by chance, just by guessing. Working in pairs, you will simulate the study. One person will be the experimenter and one person will be Joy, the guesser, and then you will switch and repeat. It's important that the experimenter should not reveal the truth for each shirt. They should simply record whether the guess was correct or incorrect. So in a minute, I'm going to partner up with Adam. We had an odd number of folks. Okay. And when I'm having him guess, I'm going to hold up a shirt and he's going to say yes or no. And then I'm going to hold up the next one. He's going to say yes or no. And we're going to keep going through it. My job as the experimenter, I have the cards in front of me. I see the correct answer, is to not reveal to him if he got it right or wrong. I'm just going to record how many he got right or wrong. Okay. And if he gets 7 correct and 5 incorrect, that is what my paper would look like. Okay. Now, when he's done with all 12 guesses, then go ahead and let him know how many he got right, but don't do it in the middle of it. Okay. Now, he, as the guesser, has to keep track of how many yeses he said and how many nos he said, because the one piece of additional information you all have is that 6 of them are yeses and 6 of them are nos. So please stick to that breakdown when you're guessing. Don't guess like 9 yeses and 3 nos. That doesn't make any sense. Everybody with me? Okay. When both of you are done, you will then come to the board, and let's say he got 7 matches and I only got 4 matches. You will put points on our dot plot. Got it? Go.